woman, Hazel Barton, mining microbes. Nickel Creek Cave winds 7 miles beneath a sleepy Kentucky mountain. Lush foliage and a 50-foot rock cliff camouflage its secret watery entrance. Looking to explore the cave's inner beauty and biology is British-born Hazel Barton, a microbiologist at Northern Kentucky University. Hazel hunts the Earth's hidden frontier, from glacial ice caves in Greenland to underwater caves deep in the jungles of Mexico, for some of its tiniest inhabitants. These single-cell organisms, called microbes, include bacteria and fungi. They live everywhere, from the air we breathe to inside our bodies, and are considered the oldest form of life on Earth. Some hardy microbes thrive in places never before thought possible, such as searing hot ocean springs and the bottom of bitter cold Antarctic lakes. Scientists refer to these super resilient creatures as extremophiles. They believe the microbe's ability to flourish under extreme conditions may provide insights to everything from life on Mars to cleaning the environment. Hazel Barton studies extremophiles that live in caves, dark, dank environments with little food, and does whatever it takes to reach her cavernous laboratories. From rappelling off vertical cliffs, Hazel rappels down a drop in the Pandora's Boxwork area of Black Chasm Cavern, Amador County, California. The cave is noted for its helictites, cave formations that grow as small twisted structures projecting at different angles. To scuba diving in underwater passages. Caves are incredibly starved, says Hazel. They're sealed off from the surface so there's no photosynthetic energy, sunlight, getting in. How do cave microbes adapt to such harsh conditions and manage to survive? Scientists aren't exactly sure, but Hazel thinks the microbes create a community that works together to stay alive. In developing her theory, Hazel collected a sample of cave-dwelling microbes living on a rock and grew, or cultured them, in a laboratory. We grow most microbes in the lab with about 15 grams of nutrients, she says. You know, a couple of packets of sugar. But these microbes live on 1,000th of 1 grain of sugar per liter of water, so the nutrients they need are tiny, tiny amounts in comparison. The cave bugs also reproduce more slowly than the norm. If you grow E. coli bacteria in the lab, you'll see a colony, a cluster of microorganisms, in 16 to 18 hours, explains Hazel. But with these guys, it may take 2 or 3 weeks. When the extremophiles in Hazel's lab finally multiplied, they surprised researchers at the other end of the microscope. We thought that we would find 2 or 3 species that are very, very good at making a living when there's no energy around, says Hazel. But we found 500 species that we wouldn't expect to see. Individually, it didn't make any sense, but when you put them together as a group, you've got organisms that can take energy and nutrients from the air. You've got organisms that can take nutrients and energy from the rock, and you've got organisms that can break down the tiny amounts of energy that are percolating out of soil into the cave. Hazel Barton and Jason Gooley collect samples of microbes living on a rock in La Chuglia Cave, which is located at Carlsbad Caverns National Park in New Mexico. La Chuglia Cave is among the longest caves in the world and is the deepest limestone cave in the United States. Put it all together, and you have a community that gets energy from multiple sources, she says. It's like Cincinnati. If you had 1 million people who did one kind of job, the city wouldn't work. But you have people who take the trash, you have people who teach, you have people who bring the food in, sell it, and everybody has his role to make the city function. In caves, the energy levels are so low that you can't make it on your own. But when you're willing to share, there's enough to go around. Hazel developed her community-driven energy hypothesis about cave microbes some years ago and has been researching it ever since. We're not exactly sure how they work together as of yet, she says. Extremophiles could be sharing byproducts, detoxifying toxic compounds, or turning over nutrients as other bacteria die. These are a few of the possibilities. Some people have a hard time accepting There are multiple explanations to what we're seeing, she says. This is my hypothesis, so I'm testing it. Others have come up with alternative ideas as to how it could be working. Grand beginnings. Hazel's interest in science developed early, with a little help from her grandfather. He was always bringing me chemistry kits, and we would blow things up in the garage, she says. He also encouraged her to read books and to watch a British television series about life on Earth. At the start of every program, the host pointed to the millions of animals and plants in the world and how each found its own unique way of surviving. He then went on to share a few of their stories. After Hazel collects cave microbes, she grows the bugs in her laboratory by feeding them special nutrients so they'll reproduce and multiply into a colony. Extremophiles grow very slowly compared with other microbes. It wasn't long before Hazel knew she wanted to become a biologist. She just didn't know what type. Then when I was 14, we did a lesson in biology in which they gave us petri dishes, and we got to brush our hair over them, stick our fingers in, and do all kinds of things, and then come back and look at them the next day to see what grew. And something fell out of my hair and landed in the dish. The next day, this gross yellow thing grew, and it was just amazing to me. From that point on, I knew I wanted to do microbiology. Around the same time, the self-described homebody took an outdoor adventure class that included a caving trip. Until that point, I'd never gone camping or orienteering or done any hiking, she says. While most of her peers were terrified during the excursion, she notes, I was absolutely fascinated. Through the years, caving became a relaxing hobby for Hazel, providing her with the ability to explore the unknown and travel to places that no one had ever been before. Still, she kept caving separate from her work. That is, until she joined the lab of Dr. Norman Pace at the University of Colorado at Boulder. A lifelong caver, Hazel rappels under the Dragon's Teeth in Black Chasm Cavern in California. And world-renowned environmental microbiologist, Dr. Pace encouraged Hazel to combine her interests and make caves her living laboratories. You always have to do what your heart says, notes Dr. Pace, who continues to collaborate with Hazel on projects. Microbial organisms basically run the planet, yet we know very little about them and cave microbiology. Since then, Hazel has traveled around the world, from Belize to New Zealand and Greece to Guatemala, exploring hundreds of caves and discovering new species. She's been featured in a movie in which she descends deep into a glacial ice crevasse in Greenland and dives into the treacherous waters beneath the rainforests of Mexico. The rock star also traveled to Venezuela. There she surveyed caves formed in large part by microbes. Hazel gazes at the delicate soda straw formations in Hollow Hill Cave, New Zealand. Soda straws are thin hollow tubes that look like icicles. They form when water seeps into a limestone cave and drips from the ceiling. Life on the rock. Endless questions and a fascination with harvesting the unknown draw Hazel to microbes. People know how cars work because they build them, she says, but no one knows how microbes work. While plants and animals may look different on the surface, they have the same basic chemistry, explains Hazel. Microbes all look the same, but they do things different chemically. That's why they can live in extreme environments. Microbes also vary more genetically, with 200 million or more species inhabiting our world. This diversity arms them with more problem-solving strategies. Hazel cave dives in the waters of Mexico's Yucatan Peninsula during the filming of a feature. Underwater caves offer scientists new opportunities to collect extremophiles, super resilient microbes that may one day result in powerful new medicines. The main drawback? Cave diving is as dangerous as it is exciting. A number of divers have died after losing their way in the passageways and running out of oxygen. If something goes wrong and you only have a couple of ways to deal with it, chances are you may not survive, says Hazel. Microbes, though, have multiple options. Some may trade pieces of genetic material called DNA, deoxyribonucleic acid, she says, or mutate and change their own information and recode it. For example, they may change the function of a protein so it performs under different temperatures. When fending off rival organisms for food, cave microbes produce poisons to attack their foes. Scientists think certain strains of the toxins may potentially benefit humans by killing bacteria that cause infections. When some of these species grow, we see, in Greenland, Hazel and a team of explorers descended deep into a glacial ice cave during the making of a movie. Buried beneath layers of blue and white ice, blue representing summer ice and white for winter, lay microorganisms frozen in time and waiting to be thawed back to life. Some of the samples Hazel collected from the wall of an ice cave to examine for extremophiles were chipped from ice estimated to be about 200 years old. Left. Sometimes the most dangerous part of caving is making it to the cave. Here Hazel, at right, and fellow caver Nancy Ohlenbach rappel 300 feet in 112-degree weather to reach an unexplored cave hidden in Arizona's Grand Canyon. Below. Hazel scrapes corrosion residue from a wall in Lechuguilla Cave, New Mexico. The soft material is residue from what had been solid limestone. The corrosion appears to be the work of bacteria eating away at the rock. Little drips of liquid that correspond to antibiotics, says Hazel. One of her goals is to identify and extract these agents so scientists can produce more powerful disease-fighting drugs. Another objective is to continue to work with NASA, the National Aeronautics and Space Administration, to uncover clues as to how life may exist on other planets. If there's any life on Mars, for example, it would probably be on the subsurface, says Hazel. We know that there's volcanic activity on Mars. We know that there has been water there in the past, and that there's a bit of evidence for present water. And we know that underground, whenever there's water and an energy source, you have a lot of microorganisms. By studying extremophiles and the chemistry of caves on Earth, scientists hope to one day make it easier to identify and locate signs of life on other planets. Buried treasures. Millions of uncharted caves await exploration beneath the Earth's surface. Nickel Creek Cave is a recent discovery, most likely formed 1.5 million years ago. It's an epigenic cave, which means it was created by rainwater that seeps through cracks in the soil. As water flows through the fractures, it picks up carbon dioxide, which turns it into a weak carbonic acid, like cola, Hazel says, that eats away at the rock. Over thousands of years, cavities form and gradually grow into channels and passages people can explore. On a crisp October day, Hazel and her team prepare to journey into Nickel Creek. Before venturing in, they huddle near the cave's entry and double-check their gear and supplies. Helmets, wetsuits, evidence of possible water sources on the planet Mars, such as these gully channels found in a crater, indicates the potential of life. Boots, gloves, rope, 3 sources of light, extra batteries, cameras, tripods, notebooks, pens, snack bags, and a waterproof case for the lab equipment. Ready to go. Today's mission: to gauge the activity of microbes that have eaten into the cave's rock and measure the conditions they live in, including the humidity and acid levels, to better understand and recreate them in the lab. One by one, the 7 cavers squeeze through the narrow passageway, leading several feet to the main cave. For 2 hours, they slosh forward, often on hands, bellies, and knees, in the wet cave, before spending another hour hiking on dry land and climbing rocks to their ultimate destination. When the team reaches the testing site, lab technician Brad Lubbers sets up the microprobe equipment under a putty-like substance on the ceiling. Everyone else breaks out the snacks. "See the rock and how soft it is?" Hazel whispers. "We've done some chemistry on it, and it's calcite, a common mineral and the main component of limestone. That's what the cave's made of. We think a flood came through and the clay got stuck on the ceiling. When that happened, it stopped water from coming in, she says. Water's always dripping into the cave, but when it can't come through the clay layer, the calcite becomes saturated. When it becomes saturated, it has a lot of moisture and energy in it, and we think the microbes use it to produce an acid. The microbes excrete out the acid in the form of waste after consuming the water, and it's believed this acid eventually turns the rock to mush. Hazel studied a sample of the soft rock in her lab and found it absolutely packed with microbes. Next, she shipped it off to NASA. We sent them a sample to figure out what the chemistry the microbes were using, and we think they're using something called methane cycling. There's a constant energy being produced, and Hazel and research student Eric Banks carefully pack lab equipment into a waterproof case before the team heads out to Nickel Creek Cave for the day. The entrance to Nickel Creek Cave is hidden beneath lush foliage and a 50-foot rock cliff. Experienced cavers, such as Deneen Sharpshare and her son Aaron Horton, shown here, wear wetsuits, boots, and gloves to get them through their first 2 hours of sloshing underground. Consumed, she says. The microbes take energy from the rock, breathe it in, and then breathe out methane. Then another organism, such as methanotroph, a bacteria that uses methane to grow, breathes that in. We think that's how they're getting their energy. What makes this unusual is that this would be the first terrestrial, or land, environment where that's been seen. It's usually found deep in the ocean. Once the equipment's set up, Brad and assistant Eric Banks activate a robot controller that pushes a microprobe into the soft rock about 40 times a minute. The probe measures oxygen amounts as well as moisture content. After countless attempts, however, it appears the researchers will have to try again on another trip. The fragile probe used to take measurements breaks each time it's pressed into the rock. All in a day's work for Hazel. She knows patience and persistence will pay off in discoveries at a later date, in the lab and beneath the earth. Going into a cave, pushing and seeing where the cave goes, and making the cave go farther than anyone else has made it go, that's man-on-the-moon exploration, says Hazel. Then there are unexpected scientific discoveries, like going into a cave that shouldn't exist and seeing things that shouldn't exist, such as weird and wonderful formations. You try to figure out why they're there and how they formed, she says. You hypothesize and test. Cave cricket. Many animals live in caves. Some, called troglobites, adapt to the total darkness and spend their entire lives in caves. Others, such as this cave cricket, which measures about 3/4 of an inch, can live in or out of caves. They're referred to as troglophiles. Popcorn formations, such as those pictured here in South Dakota's Wind Cave, abound in Nickel Creek Cave. Also referred to as cave coral, popcorn-like speleothems are made out of clusters of the mineral calcite. Quick questions. Question: how does it feel to explore underwater caves? Answer: it feels like flying. If you want to go look at something, you kind of kick off or just glide toward it. Psychologically, it's a lot harder than other types of caving. You have to really be secure in your equipment and know what you're doing. If something goes wrong, such as getting lost or tangled in the line, you only have a couple of minutes to deal with it, as opposed to in a regular cave where you have days before you really start getting into trouble. You can't fool around when you're cave diving. Question: where are the best caves in the world? Answer: France, the United States, and Borneo. It depends what you're looking for. Mexico has some great underwater caves. Question: what's been your most exciting moment in a cave? Answer: one of the most exciting was the discovery of the Lunatic Fringe Room in Wind Cave in South Dakota. We were doing this exploration, and we were pushing and pushing and pushing, and we found this tiny hole. So we pushed through it, and we got into this room that had a big hole in the floor. We couldn't see a way down, so we came back a month later with a rope. It turned out to be a 60-foot pit that dropped into a room about the size of a cathedral lined with crystals. Hazel nurses an injured arm received when a boulder broke loose in a New Zealand cave. After surgery and 37 stitches, she soon returned to caving. Question: have you ever been caught in a narrow opening? Answer: no. I mean, you don't want to put yourself in that situation. That comes with experience. I've certainly crawled into things, and I've thought, oomph, it will take a lot of work to get back out. But if you panic, then you get stuck. The trick is to stay relaxed. I've pulled people out who've been trapped, as well as a guy who slipped. He was in a wide crack, and he slipped and fell into a narrower crack. So we had to pull him out, and that took about 6 hours because he was struggling. When you struggle, you get bigger. So I've never felt trapped in a squeeze. You really don't want to go into something if you don't know whether you can get back out. Question: have you been seriously injured in a cave? Answer: yes. I was in New Zealand on a photo trip, and we were in a stream passage where you could either walk through the passage or climb up to the ceiling and stay dry. Now, photography trips are notorious for being very slow and very long, and you get really, really cold. I didn't want to get wet and cold, so I decided to climb up to the ceiling and stay dry. There was a big boulder in the passage, so we climbed on top of it and then climbed up to the ceiling and traversed. What I didn't know was that there had been a flood in the cave the day before that undermined the rocks underneath and loosened the boulder. So when I stood on it, it went phew and started to move. I jumped and got free, but it gave a blow to my wrist. If I didn't have the caving experience and hadn't jumped as soon as the boulder moved, I would have lost my arm. Top. Hazel squeezes into a new room discovered in Black Chasm Cave in California. Bottom. Hazel examines specimens in her lab. Question: what are some of the steps you recommend to keep safe? Answer: there are a number of rules that adult cavers never break, or break at our peril. Get the appropriate training. Caves are inherently dangerous. Wear a helmet. Have 3 sources of light. Tell someone where you're going and when you'll be back. Wear appropriate clothing for the cave. Leave nothing but footprints. Everything that goes into a cave must come out, including human waste. Take nothing but pictures. Kill nothing but time. Hazel descends to Lake Slytherin on the day of its discovery in an area of California's Black Chasm Cavern called the Chamber of Secrets.